Percent dissociation. What is dissociation? Dissociation is the splitting of molecules into smaller molecules or atoms. For example, hydrosulfuric acid will dissolve into hydrogen and sulfur ions. Salts will undergo this transformation when they react with water. When reacting with water, strong acids and bases completely dissociate, which means none of the non-ionized acid or base remains after the reaction. In the example on the side, you can see hydrochloric acid on the left beaker, but after adding water, all that remains are hydrogen ions and chloride ions. On the other hand, when you react water with weak acids and bases, they will not completely dissociate. On the image on the right, you can see acetic acid molecules on the right beaker, and after adding water, there are still remaining some acetic acid molecules. This is called partial ionization. Percent dissociation and how to calculate it. Percent dissociation is the ratio of concentration of the ionized acid at equilibrium divided by the initial concentration times 100. Example 1. When half a mole of acetic acid is dissolved in enough water to make 1 liter of solution, the measured pH is 2.5. What is the percent dissociation of the acid? First, we calculate the initial acid concentration. We have our volume and we have our moles, so we can use the C equals N over V formula to calculate our concentration, which is 0.5. Next, we're going to calculate the dissolved acid concentration. We know the pH is 2.5, so we can plug that in to get the concentration of the hydronium ion. The hydronium ion's concentration will be equal to the dissolved concentration of our acetic acid. So we have the dissociated ion concentration and the initial ion concentration. We can plug it back into our formula and get an answer. The percent dissociated percent that we get is 0.63, which means that 0.63% of the acetic acid has been dissolved into its ions. Propanoic acid is a weak monoprotic acid that is used to inhibit mold formation in bread. A student prepared 0.1 solution of propanoic acid and determined the pH to be 2.96. What is the percent dissociation of this weak acid? The first thing we should do is make our ice table. We know the initial concentration of the acid is 0.1 moles per liter, and the concentration of the conjugate base and the hydronium ion are both 0. And after a change of X, we have our concentrations in equilibrium. We know the pH, so we can use that formula to figure out the concentration of the hydronium ion at equilibrium. Using this, we can find that X is also equal to the hydronium ion, which makes the conjugate base also equal to the hydronium ion. So now that we know our X value, or our dissociated concentration, we can plug that into our formula and get an answer. We get an answer of 1.1%. This means that 1.1% of propanoic acid has been dissolved. Common mistakes and tips. The dissociated concentration is not the concentration at equilibrium. Rather, it is the X value in the ice table, or the change in concentration. The percent dissociation should also be around 1 to 5%. Also, the concentration of the hydronium ion from the auto-ionization of water is negligible because it's so much smaller than the concentration of the hydronium ions formed from the ionization of the weak acid. Thank you for watching.